In this module, we'll define two C language features that allow you to define aliases for types. The first, Typedef, allows you to define an alias for a type and is evaluated at compile time. The second, Macros, allows you to define a keyword that is replaced by a specified string when your program is processed before being compiled. Both these features are pretty straightforward to use, but we'll discuss a few gotchas in the videos. Let's get started with Typedef. If you've been watching these videos in order, you've already seen the type size_t. It is the type of malloc parameter and the return type of sizeof. This line, usually found in the C standard library file standarddef.h, declares size_t to be an unsigned int. Typedef is the keyword. It allows you to define a name, in this case size_t, that refers to an existing type, in this case unsigned int. In the future, if you decide that you'd rather size_t be an unsigned long, you could just change the typedef, and every piece of code that uses size_t would start to use unsigned long values rather than unsigned int values. Note that this doesn't create a new type in the sense that structs do. You're not creating a new composite type with components that have their own names. Instead, you're providing a new name for an existing type. Some programmers argue that Typedef makes your code easier to read. For example, suppose you had a program that is dealing with ages and shoe sizes. Both values are represented by unsigned integers. But you could use Typedef to give them their own recognizable types. Then, in a function to print your skate size, 2 sizes larger than your shoe size, by the way, you could make the parameters type shoe size_t. Then it's clear what kind of value your function should take, so you won't put an age into your boot size function. On the other hand, other programmers in the C community argue that this actually makes the code harder to read and modify, because when you see the type shoe size_t, you won't necessarily know how to use it. Can you add integers to it? Is it a string? The typedef doesn't prevent a programmer from passing in an age, or for that matter, a character. The compiler won't complain about a shoe size_t, age_t, size_t, or any other value that can be interpreted as an unsigned int. So someone reading your code can't rely on the compiler to point out errors. They must find the typedefs so they know how to use the types you've declared. One place where most people agree that Typedef does make your code easier to read is when you declare a struct. Let's consider this code fragment that might look familiar to you from the videos on structs. When we want to declare a struct student, we had to say struct student every time. And when we wanted P to point to one of these structs, we had to say struct student star P. Let's add a typedef to our code to make it clearer. We will use the common convention that the struct itself is named with a lowercase name and the typedef name starts with an uppercase letter. We are aliasing student to be the type struct student. And now S is type student, which is type struct student. And P is pointer to student, which is type pointer to struct student. This is very common, so C allows us to combine the definition of the struct and the typedef. You need to add typedef here so that we are both defining the struct and using typedef to create an alias for it. And then add the name of the new type here before the semicolon. You can even omit the name of the struct, student, although there are often times when you still want it. And there you have it. We've used typedef to create a simple alias for our struct.